The next type of diagram we still have time to consider and use is the state diagram, which represents an object which is implemented as a state machine, right? So, for instance, in our semester project, we have this handout. Our business requirements indicate that we have the elevator movement simulation, and I think that somewhere down the line we have a description for elevator states, and here it is, right? So when we have those elevator states, what we can do, let me try another whiteboard display right here. So over here, if I detect that, for instance, elevator has a set of states, it clearly indicates to me that I can take advantage of it and model this object through a set of states. The set of states is captured through simply states drawn on the whiteboard like this. So we can have maintenance state for the elevator. We can have standing state. We can have loading, right? Loading. We can have moving up, and we can have moving down, right? And this is not limited to. But those are some major states that we can indicate in the modeling of the elevator class, for instance, right? And so what we can do is that you can say that if you're moving up, the only way you can switch over to loading is that you first have to go to standing state, right? So you have to basically stop, right? And then you go to standing. Once you go to standing, you can go to loading, right? You can say open doors, right? And as you open the doors, you go to loading. As you close the doors, you go back to standing, right? So you say close doors over here, and when the doors close, you can go to standing. And if you want to start moving, you can go from standing to moving, right? You can go from standing to moving, and you can say start, right? Start. So these transitions typically, standing, moving would have both, right? Start, moving up, start, and so these are the state transitions that are very, very helpful to represent the behavior of object with complex internal implementation, right? So you want to formalize it, and so what you do is you can take advantage of a state diagram, right? So these are my states right here, and I can transition from one state to another by using these arrows. So this is an example of UML state diagram. However, UML state diagram is basically incomplete or not totally useful until we formally describe these states in some sort of a table, right? So we need to have a table of states right here, and for each single one we can write down the state, right? The state name. Oftentimes you also add an ID to your states, right? So it may be useful to actually add some sort of ID field, right? So for instance, maintenance may have ID 0, for instance, right? Standing can be ID 1, and so forth, right? So then you can basically write information about events, that transition you to a different state. So you can say event, right? Event, state and event, and we can say that for instance for event like moving up over here. If the event is stop, right? You transition to state, new state. A new state would be, so when we're moving up and we say stop, the new state will be standing, right? Because we said stop. So these are examples of states and state transitions. You can describe all states separately, providing descriptions to each state, but this is this can be combined with state transitions. State transitions, and basically you can describe, and you can also of course have like comment field that would provide additional details about those state transitions. So typically the UML state diagram is accommodated by the table. Perhaps you can just basically have a table of states, right? So you can have a table of states which simply provides ID, state name, and description, right? So this is ID, state name, and description over here. So you can fill out basic information about your states over here, and then you can also provide a set of state transitions, and everything can have its own set of IDs. For example, you can also have separate events, right? So you can say events that cause state transitions. Similarly, you can basically describe your events in a separate table. So typically, the whole approach to state management, state diagrams, and state transitions is through the set of tables. But a good indication of those states and state transitions, of course, is represented by the UML state diagram, right? So these are basically the highlights of the states. And of course, today we may not have enough time to finish the detailed talk about everything, but this should give us a pretty good overview today of like what we're dealing with. So this is the scope of state management through UML state diagrams and related tables. And so what I would like to do is essentially go back here and just to say that the state, so we can say that an elevator class can have an implementation of a state machine. And state machine formally recognizes states and state transitions and events that trigger those transitions, and of course conditions which may be involved in those transitions, right? So, but that's what the state machine is. Basically, is a class that implements a state machine type of object. So typically, that state machine is very effective modeling the behavior of a single class, right? Not combination of classes, but a single class, like an elevator, right? So you don't want to combine into this picture, right? So if that's the picture that we're dealing with, you really don't want to combine into this picture other concepts which may be involving a bank of elevators. You just want to focus on a single elevator class and say, okay, these are the states and these are the transitions and events that are involved in its life cycle. So state machines are modeled by state diagrams in UML. State diagrams should be provided for objects with interesting dynamic life cycles, right? And interesting means typically a set of restrictions, right? So maybe you don't want to jump from moving up to maintenance, right? Again, perhaps you want to stop first and then do something to go to maintenance. that's interesting. Interesting from what perspective? From the business perspective, from what we actually write in order to either, run a simulation, or maybe if you want to write some kind of, middleware for an actual equipment that controls an elevator, right? Those states and acceptable transitions are very important, because if you misuse these states and stuff like that, you can even damage the elevator. Or if you're writing some code for your hard disk microcontroller, you could damage the drive if you're not using the right states permissible by the hardware, right? Okay, so state diagrams should be provided with interesting dynamic life cycles. Interesting dynamic life cycles, like I said, they're essentially should be recognizable as different states. So state diagrams are perhaps the oldest version of diagrams that survive different stages of development of different programming languages, software and hardware, and they were around since 1960s, which is very impressive. So they're very, very effective. Like I said, we're mostly looking at a single class dynamics. However, this set of states can persist and continue through a life cycle of an elevator that could be going through multiple use cases, right? So there could be normal operation use case, could be maintenance, could be emergency, and still the same states could be used in all of these various use cases, right? So that's why we say that so that those state machines demonstrate dynamics across multiple use cases. So that's an interesting observation, and we should basically just take a note of it. More details regarding conditions when state diagrams become almost a necessity and just really formalize the situation. Objects are created and destroyed during the runtime. Objects accumulate the values of their attributes over life cycle. Objects represent equipment with distinct operational cycle, like an elevator in our case, right? Objects constructed in stages. Objects that represent requests or tasks to be done, so that we have a recipe, right? And through the list of items on that recipe, essentially we step through, and each step may indicate transition to a different step. We're getting closer to complete a certain task. So those types of things can be implemented as state machines. And objects involved in dynamic relationships, in case where they're in and out of relationship. So I can give you another example of this. For instance, we say object accumulate the values of their attributes over their life cycle. So a quick example to perhaps conclude today's set of presentations. Imagine that, perhaps let me just save this and switch over to the next segment.